We're starting the unit on matrices, and matrices are used to solve systems, so we're going to review systems real quick. There is one section of the quiz that is totally review from Algebra 2. So you all have this packet, right? Okay, so notes are on the first couple of pages, the examples, and then you have to do problems on worksheet 3 and 4 tonight. This says solve the system by graphing. You would just graph these two lines and find where they intersect. Since those are already in y equals form, I'm going to skip to number 2 and do this one with you. What would you do if you needed to graph this line? You want to get... I don't know. What do you want to do? Get the y by itself so that you can graph it using slope-intercept? Is that what you would prefer? Okay, so you have a couple options. You could add the y over this way and subtract the 4 back this way, or you could subtract the x over to the other side. And then go through and change all the signs. So you get y equals x minus 4. So that one starts down at -4 and has a +1 slope. Ooh, I'm not doing too bad on the graphing yet today. Okay. The other one, if I subtract 9x over to the other side, we'll say y equals -9x plus 6. That one starts way up here, goes down 9 and over 1. So I think that's where they intersect right there. My horrible graphing. But the answer to this question then is that the system is consistent, meaning it has a solution, and the solution is what ordered pair, guys? 1, -3. Be very careful that you give x and y. Okay, how could we check that that works? Can we just plug it in one of these up here? Guys, there are infinite points on each of those lines, right? What is true of this one? It has to work in both. So just checking it in one doesn't really prove anything, okay? If I put it in the first one, 1 minus -3 equals 4, that's true. If I put it in the second one, 9 times 1 plus -3 equals 6, it does check in both. Everybody okay? Like that. All right, number 3 and 4 are inequality questions, okay? I'm not going to do 3, but just remind me, which of these symbols mean, or what do these top two mean in terms of graphing a line? When it's less than or greater than, the line has to be dashed or dotted. Do you remember that? Okay. If it is an or equal to, then it is a solid line. And then the other thing is, these are the questions where you have to shade, okay? And a greater than or equal to, you shade where the y-axis points above the line. And a less than or equal to, you shade where the y-axis points below the line. Does that sound familiar to everybody? You can certainly do those if you want. I'm going to move on and talk about the next one because there's a little extra stress on the next one. What do we have to do first on this one? We have to get the y by itself, and what does that result in? I don't know why I wrote that one down first. This is a greater than, not an equal to. Okay, so if I subtract 3x to the other side, I have -4y is greater than -3x minus 28. But what do I need to do then? If I divide all those by -4, does anybody remember what happens? Yes, I have to flip the greater than to a less than, okay, because I divided by a negative. So this is going to become positive 1y is less than, okay, and then 3/4 x plus 7. Did I reduce everything right? Okay, so I go up to 7, and my slope is up 3 and over 4, or down 3 and back 4. And is that one solid or dashed? Yes, this is a dashed line because the points on it are not included. If you graph on the quiz and then all of a sudden you go, oh, that was supposed to be dotted, just, you can write a note by it, you know what I mean? Because we all do it. We forget until after we've already done it. It's pencil, you can just erase. But, and then do I shade above or below? This is, remember we had to flip it. It is a less than, so I shade below. And if you're confused, guys, look at the y-axis, where the y-axis is pointing below, okay? That's the side you're shading on. Okay, now I don't want to shade too much because I got to come back and do a whole nother line here, right? All right, the other line, 9x plus 8y is less than -64. If I subtract 9x over to the other side, this time I'm dividing by an 8. That's positive, so it doesn't flip. I got a -8 for my y-intercept. I'm supposed to go down 9 and over 8. That isn't happening for me. So I have to do what? Yeah, I could put the negative on the bottom number, so I could go up 9. This was -8, right? So up 9 and back 8 should be here. I'm guessing that that's the spot it was supposed to hit with my green 1, 2. Down 1, 2, 3, and back 4. Okay, so here's, is this one solid or dotted? Dashed, yes, it's also dashed or dotted because it's not an or equal to. And it's a less than. Where does that mean I am shading? Below, which is here where the y-axis points below, so it's this side to the left. Now, where is the area that is double shaded on this coordinate plane then? Yeah, it's below the green and below the black, so it's this little bit down here. So only points down in that area work. Mostly in the third quadrant, right? They would not all be in the third quadrant if we were to continue it out. Any questions about those? Everybody get when it's dotted, when it's solid, when you shade above, when you shade below? I can go back and do number 3 if you need me to. All right, numbers 5, 6, 7, and 5, 6, 7 are solved by substitution. Do you remember what solved by substitution is? Yeah, like this one says y equals, so you could put it up in this one. I'm not going to do that one. I'm going to do this one. What happens on this one when they both say y equals? Yeah, you just put this mess and you plug it in here so that it says 9x plus 6 is equal to -3x minus 6. Now the thing about these is we're still solving a system. So the answer is not just x equals. I got -1 for x. Did anybody else get -1? Okay. What do you have to do to finish solving though? yeah, put it back in either one, doesn't matter. So we get y equals 9 times -1 plus 6, which would be -9 plus 6, or -3. So I have as an ordered pair for an answer -1, -3. If I wanted to check it in both, I'd have the y equals -3 times the x minus 6, and the y equals 9 times the x plus 6. Let's see. This would become 3 minus 6 is -3, so that checks. And this is -9 plus 6, which is -3. That one checks. We good? Any questions on those? Okay, number 7 is a weird one. That's why I left that one for us to do instead of 5 together. First of all, it does say we have to solve by substitution, but neither of these is set up necessarily for substitution. So it looks to me like it'd be a lot easier to take that second one and just subtract the -2x over to the other side. Does that seem okay? Now we're going to substitute this into which one? Yeah, this is actually the second equation rewritten, so it has to go back into the first one. You can't substitute back into itself, though it's going to have something weird happen here. We have a -4x minus 2 times y, which is being replaced with -2x minus 8, and that's all supposed to equal 7. What happens? So I have 0x plus 16 equals 7. This is not true, right? It's never true. It's not possible. So this means there is no solution. The vocabulary for this is an inconsistent system. Because it has no solution at all. Does anybody know what would happen if we graphed them? How is it possible to have no solution?
That neither line can intersect.
Okay, what is that called in geometry? These would be parallel lines. Okay? Everybody good? If you had solved them for y equals. But if you're doing substitution, you're probably not going to do that. Yeah, if you'd gotten them in both in y equals form, you would have probably noticed they had the same slope. All right. This next section is solved by elimination. This is my personal favorite. This is what I like to call the call on the algebra fairy. Okay? This is where you add two equations together. Do you remember you did this in Algebra 1 and it said something like this? And you went, oh, look, if I add these together, I get 2y equals 8. Y equals 4. I plug it back in. Remember those? Okay. But this is not as easy as that. Okay, starting with number 9, I have to do what to make... This was a weird one, by the way, but how can I wish that for something that would make these come out 0 or the y's? Multiply through by what? Okay, if I multiply through by a 4, I'll have -12, -16, and -20. If I do by a -4 on both sides, all the way through by a -4, and rewrite it underneath here, I get 12x plus 16y equals 20. Now when I go to add these two together, what happens? Yeah, it's all 0. However you want to write that, it means they're exactly what? Yeah, the same line. These are the same line. The same line. Therefore, it means the system is called dependent. Dependent and consistent. What that means is it has at least one solution, and dependent means the lines are really the same line. I don't believe that that vocabulary is anywhere on a quiz, okay? It does mean they're the same line, so there are actually how many solutions? Infinite solutions. Now, I really hate when students just say all real numbers, because do all real numbers work? Can 1, 1 work? You could put in any x, but you'd have to find a matching y that's on that line. Does that make sense? You could put in anything for y, you'd have to find a matching x. There are infinite solutions, but it's not just like 0, 0, 1, 1, 2, 2 all work. It's whatever work. Even 0, 0 doesn't work, right? If I put a 0, 0 in, I don't get -5 and I don't get -20. So let's try one more where we actually do have to use elimination. Now, I don't know how to make a -2 into a 3 or a -4 into a 7. Yeah, you have to multiply both equations through by something. Does that sound familiar? Okay, so would you like to make the x's go away or the y's? Anybody have a preference? X's? Okay. So we need to make what common factor here? 6. So you want to make the top a +6. Multiply all the way by 2. And on the bottom, we're going to make that a -6 by multiplying through by a 3. All right, so the top one will become 6x minus 14y equals -8. Did I do that right, guys? And the bottom one, if I multiply all the way through by a 3, will be a -6x minus a 12y equals a 60. All right, let's see what happens. I get -26y equals +52. If I divide, that comes out -2. And then I need to plug that back in, and I can actually use any of these equations. I think I'll go to the very first one, because it has a positive here. -7 times -2 equals -4, which is 3x plus 14 equals -4. Did I do something wrong? -14. Oh, I don't know. I can't add in my head. It's -18, and then it divides, and we get -6. I thought it wasn't coming out a nice number, and I don't think any of these are fractions today. So if we wanted to double check, we would have 3 times -6 minus 7 times -2 is supposed to equal -4. Well, that would be -18 plus 14 is -4. That one checks. And the other one is -2 times -6 minus 4 times -2 is supposed to equal +20. 12 plus 8 is 20. That one checks. Okay. I didn't really write the answer anywhere, though. What's the answer? -6, -2. Good job. Should be an ordered pair. Everybody okay? All right. 11, I don't really want to take time to do with you, but does anybody know what you might do for the first step to make that a little bit nicer? Okay, but we're supposed to solve by elimination. Okay, so if I multiplied this top one through by 2, so that I had 2y plus 1x equals 5, I could then rearrange it and say 1x plus 2y equals 5, and I could rearrange this one and write it underneath here, 5x plus 7y equals 13, and then maybe multiply the top one through by -5, right? Okay. So it just would take a little extra manipulation to get it to look a little nicer. All right. We are skipping, look at all those lovely steps. Choose a variable to eliminate. Choose two equations and add or subtract to eliminate the chosen variable. Then choose two different equations to eliminate the same variable. Solve the new system with two variables, then plug back in and find the third variable. Do you think there's any room to make a mistake in that disaster? Hey, those are miserable to do by hand, and that's what matrices were invented for, so we're going to not do these by hand because we're just going to not spend time on that. Is that okay with everybody? So we are skipping all the way down to the word problems. This is number 15, I believe. Okay. It says the senior class at high school A and high school B planned separate trips to the county fair. The senior class at high school A rented and filled 12 vans and 14 buses with 888 students. High school B rented and filled 2 vans and 6 buses with 324 students. Each van and each bus carried the same number of students. Okay, I don't know about you, but I am kind of overwhelmed with numbers right now. And actually things I don't know, right? High school A, high school B, van, bus, girls, boys, fair, I don't know what's going on. I always go to the last sentence to figure out what it is I'm actually finding. It says find the number of students in each van and in each bus. So my variables, I'm just going to use X and Y, are going to be number of students in a van and number of students in a bus. I don't know if anybody looked closely at the post-test, pre-test, post-test, but there was a question that is a word problem like this, and you get partial credit for telling me correctly what X and Y stand for. Okay? Please don't write van and bus. Well, you can use V and B, but it's not the number of vans or the number of buses that we're missing, right? It's not the color, it's not the cost. So be more specific. It's the number of students. And you can abbreviate, ST or something if you don't want to write it all out. But don't just write van and bus. It's the number of students. All right. Then these are actually my favorite kind of word problems because there's just one sentence per equation. Says 12 vans and 14 buses took 888 students. Can you change that to an equation? 12 in every van, or 12 vans at X students each, plus 14 buses with Y students each, total 888 students. And then it says high school B had this issue. So then what's that equation? 2x and 6 number of students times a bus is 324. Now, my plan for today was to just have you set these up. Do we need to do one more elimination problem? Are we okay? You want to do elimination real quick? What would you multiply through by to solve this system? Divided by -6, okay? Now these are kind of miserable numbers, so here's the top one. The bottom one becomes -12x minus 36y equals, someone helping me? 2. It's a good year, so my dad was born in 1944, okay. Combine these and we get -22y equals, yep, I don't know. Somebody help me. -150. Okay. Does that divide nicely by -22? Please tell me it does. I don't want to have to cut any students in half. So 48 students per bus. Whoops. Okay, now if I were to put that back in somewhere, right here, this green one, That sounds good. So we have 2x plus 6 times 48 equals 324. Move the words out of there. It's 2x equals, what do you get when you multiply? Subtract that over there. What? So we get 90? Does anyone else? Are you sure it's not 9? Okay.
Oh, I see what I did. I typed the wrong number.
So this is 36 and it's 18? Did you get that, Cameron? Okay. I'm like, it's not seeming reasonable for a van and bus. Okay. I don't know very many vans that can fit 18, but maybe those little mini buses, they call them vans. I don't know. All right. 18 students in a van, 48 students per bus. Okay, we good? All right. Yeah. We need to talk about this one, though. Number 16. Eek. Students totally struggle with this idea. A boat traveled 252 miles downstream and back. So the trip downstream took 12 hours. Okay. The trip back took 36. I believe this is 252 miles downstream and then 252 back, okay? The 252 is each way. So it's 252 downstream. That's a distance. And then it's 252 back. Okay. Now, the trip downstream took time of 12 hours. The trip upstream took 36 hours. What is the speed of the boat in still water, and what is the speed of the current? What? How can we...
You first have to figure out how fast you're going inside the water generally.
Well, we have two unknowns. Yes, we don't know the speed of the boat or the water. But when you are going downstream, what does that mean, guys? Yes, the current is helping you. So the rate going this way was what? The speed of the boat plus the speed of the current, which is y. Okay? What is the rate going this way? Speed of the boat minus the current. All right, now, we could do rate times time equals distance, but could we make those a little bit easier? What's distance divided by time? That's rate, right? So what if you did 252 divided by 12? 252 divided by 12 is what? 21? Okay. So on this downstream trip, x plus y has to equal 21. All right. What about this one? This was the distance. So we have 252 divided by 36 is distance divided by time, gives us a rate of what? 7, okay? And what is 7 equal to? The rate is x minus y. Now, do you see why I divided first? Because they're really easy equations now, right? If we add them together, we get what? So divide is 14. If we put a 14 back in there, 14 plus what is 21? So, what's the answer to the question? Speed of the boat is... That's supposed to say boat. I don't know what just happened. The boat is 14. Was it miles per hour, guys? Yeah. And the current is 7 miles per hour. Okay. You could have also done rate times time equals distance and filled in a little chart like downstream and upstream and done this is x plus y and x minus y. This was 12 and 36 and this was 252 and 252. And then you would have had to multiply these together, x plus y times 12, and x minus y times 36, and set them equal. Okay? Just giving you some options. We just divided first, so we didn't have to deal with those big numbers. All right. Do we need to set this one up? Tickets to a play, 12 adults, 3 students, 120. It's just like the bus and van question, isn't it? Can we just skip that one? I want to do 19 and 20. Whew. And these are going to take a little while. So this is the new stuff. It says solve each system of equations. What's wrong? Are these linear? One of them is, right? I don't know what shape the other one is. It would actually be hyperbola, I think. Okay, but you don't know that yet. All we're doing is we're going to solve by substitution. Okay, when you do these, you have to use substitution. Okay? Do you want to get the x or y by itself? Yeah, this equation down here looks like it would be a whole bunch easier to get the y all by itself. So what would it say if I got the y by itself? Okay, negative 3x plus 2, or 2 minus 3x, either way you want to write it. Okay, so now we're going to plug that in to the first equation, but you got 2 spots to put it in, here and over here, which means you've got to square it. Okay, this is a lot of algebra. I'm going to go kind of quick so we don't run out of time, but it's x squared minus 2 times this quantity squared plus 7x minus this quantity again minus 7 equals 0, and of course it just doesn't quite fit.
No.
Okay, I'm going to go over here and square this just because I want it out of the way. When I FOIL that out, I get 9x squared minus 6x minus another 6x and a plus 4. or 9x squared minus 12x plus 4, and then I have to distribute that negative 2 in a minute. And then here we're going to distribute that negative because I want to get rid of that parenthesis. So I get plus 3x minus 2 minus 7 equals 0. Okay, it's going to get a whole lot nicer in a second here. X squared minus 18x squared plus 24x minus 8 plus 7x plus 3x minus 2 minus 7 equals 0. Okay, combine like terms and life will be much better. What do we get here? Okay, how many x's? I got 34. Okay. And then we have a minus 8. And back here, these two. So negative 8 minus 2 is negative 10, minus 7 is negative 17. Oh, goody. What can we do to all that? By negative 17, right? Or take out a negative 17. So we get x squared minus 2x plus 1 equals 0. Which factors? Minus 1 and minus 1, right? So x equals what? Positive 1. Most of the time, these have more than one solution. This one happens to have only one solution. If you plug that back in, where can we plug that back in? Where's the easiest spot to find y? The one that said y equals, right? So y equals negative 3 times 1 plus 2, which would be negative 1. Did I do that right? So the solution we got was 1, negative 1. Okay, then you could grab your calculator and type it back in this first equation to make sure it worked. If I put a 1 in, I'd have 1 minus 2 times negative 1 squared. Well, negative 1 squared would become 1, so that would be minus 2. Plus 7 times 1 minus negative 1 would be plus 1. Minus 7 equals 0. Does that check? Yep. Does check, okay? I think I'm going to get that off the top of the notes. Everybody's going to go, what in the world is that? They look at the notes later. Okay. One more. What do you want to do here? Last one for the day. If I add the y over to the other side, and what else? Subtract 2. Anybody getting y equals 2x minus 2? Okay. Yep, we're going to plug it in for all the y's. So we're going to plug it in here and here. So we have 4x squared plus 2x minus 2 quantity squared plus 38x minus 3 times 2x minus 2 minus 42 equals 0. What's the most common mistake people are going to make? Yeah, they're not going to FOIL that out right. 2x minus 2 times 2x minus 2 is 4x squared minus 4x and another 4x and a plus 4. So I have a 4x squared that came with it. All of that is a 4x squared minus 8x plus 4. And I don't need those parentheses. I just want to show where it came from. At least we don't have anything to distribute this time, right? plus 38x, except I lost the 8. Okay, distributing back here gives me minus 6x plus 6 minus 42 equals 0. Okay, again, I'm not distributing, so those parentheses don't need to be there, but it's 8x squared. How many x's we got, guys?
No.
24. And then I got 4. And plus 6 is 10. Minus 32. So we can take out an 8. We can throw it out, or we can leave it out front. It doesn't matter. It's not going to equal 0. So we can just divide it away. Now, x plus 4, x minus 1. Anybody getting negative 4 and positive 1? Is that what you got, Isabella? Negative 4 and positive 1? Okay. Now, this is where students somehow get a little confused. And I don't really understand. If you got this far, you should be overjoyed and you should get the last little step right. Each of these are separate x values, right? And each one has their own y value that goes with them. So if x is negative 4, then I have to plug it back in here. So I'd have 2 times negative 4 minus 2 equals y, which would give me negative 10, anybody? Okay. And that's totally separate from if x equals 1, and I put it back up there, 2 times 1 minus 2 equals y. Is that 0? Okay. What students sometimes try to do, guys, please don't do this, okay? They say, well, x is negative 4 or 1, and y is negative 10 or 0, and then they start making up all kinds of ordered pairs. Do you see what I'm saying? Each y goes with specifically with an x that it came from. So there are 2 places those should intersect. I wish I had time to check. I hope we did it right. Came out nice, so I'm kind of thinking we did. All right, so your homework tonight is to do the ones on worksheet 3 and 4, and I need to know if you have questions tomorrow so that I can go back over whichever kind you had trouble with. Because then we're going to start matrices tomorrow as well. And what is assigned on 3 and 4 is on the little homework check sheet, right? I don't know if they're circled on the actual packet or not. But it's on the little homework check.